Hello, my name is Agustin Rafael Martinez. I am a PhD student. I teach in this faculty, assisting Professor Hernan Wilkinson, in the subject of software engineering. Today, I will present the project implemented in Smalltalk. I use Quiz Smalltalk, which is a Smalltalk oriented for education. I will present a new programming language. This programming language has a minimal visual version. It has 4 fundamental symbols that are predefined symbols. The rest of the symbols are user-drawn symbols. This is a prototype, a laboratory prototype, and the intention for the future is to allow children to program with their own drawings. I will start the presentation with some video captures, and then I will make a little live demo. The intention of the videos is to give an intuition of what this language is about. Es un tábano. So this is the minimal visual environment to program with this language. Here it's very easy to draw new symbols, drag and drop them, and define simple programs using those drawings as symbols. It is possible to define simple programs such as the germination of a seed, and also more complex socio-environmental issues such as forest fires, firefighting. These are domains that are not essentially symbolic, but they can be abstracted and represented through drawing symbols. With my son, I have been playing with these magnetic blocks since he has 3 years old. Today, he has 10, and we continue to play with these magnetic blocks. What I like about them is that they fit together by their smooth size. They don't have the usual sockets of other building blocks. They are so dynamic, so easy to play with, that very young children can play with them. For me, to program is to build theories, as Peter Naur said. A program for me is a construct of interlocking concepts, as proposed by Fred Brooks. The name of this project is representar, which in Spanish means to represent. This highlights the vision of the project. To program is to create epistemic representations of knowledge. I like this idea of Alan Kay that terrific ideas hide behind good ones. And I will take this notion of Arthur Koestler of bisociation, the relation of previously unrelated elements. I think there is a terrific idea in the bisociation of these magnetic blocks and programming. With this minimal environment, it is also possible to define abstract domains such as natural numbers and addition, at least partially. Another domain that can be represented using drawings, which is abstract, are Booleans and can be represented completely. I will show you this example. So here I have some drawings already. There is a drawing that represents true, false, and, or not, and a drawing that represents the abstract notion of Boolean. I will start to define the AND operation. True and a Boolean reduces to the value of that Boolean. False and a Boolean is always false. True or a Boolean is always true, and false or a Boolean takes the value of that Boolean. I have also to define that not true is false and not false is true. And for this program to be complete, sorry, good, thank you. And for this program to be complete, I have to express that true and false are Booleans. The true and false are categorized by this drawing that represents the abstract notion of Boolean. In this way, it becomes an abstract notion. I'm trying to. So you may have seen that at the bottom I have some expressions on the left, and on the side, on the right, I have some results. I can throw expressions here and see the result of evaluating them. Usually, a programming console is for writing text. Consoles are for text. But here I am proposing a visual console where we can put visual expression, our drawings, in one side and see the result of evaluating them in the other side. This is not just a console, it's a read, eval, apply loop console, and it also updates live. When I change the program, the console updates. This is a new thing in visual languages for children. I will take this domain I just implemented of Booleans, and I will implement a typical notation of procedural languages, which is if-then-else notation. For that, I have some drawings already. Some drawings have text. We can draw text, and in this way, text starts relating with the drawings. For define if-then-else, I need to define only two substitutions, one for each truth value of the condition. If the condition is true, then a phrase, here is a red phrase, else a blue phrase. If I have something of this form, the phrase that should be evaluated is the associated with the then, in this case, the red one. Unlike when the condition is false, then we have a red phrase, else a blue phrase. The phrase that should be evaluated is the blue one, the associated with the else. There is something more I have to do for this to work. I have to express in a way that these phrases are phrases, that these dialogue balloons, red and blue dialogue balloons, which are just drawings, I have to express that they are phrases. And for that, I will use the joker, the wildcard, which already represents any sequence of symbol, already categorizes any sequence of symbol. So if I take the wildcard, that is a general category, and put it under another category, I made that other category as general as the wildcard. So in this way, I define it that the blue balloon and the red balloon are general categories. So here I have the expression, and if-then-else with a condition and two different phrases, and here is the result. An important thing in an if-then-else notation is that one of the phrases should be evaluated and the other should not. This is crucial for an if-then-else to work. And the the readable applied loop console doesn't help to know if the two phrases are evaluated or not. Usually, inspecting the execution or debugging is considered complex for children. Here, with one click on a result, we can have an idea of what is happening in the execution. I have here the initial expression, and I know now that the first thing that was evaluated was the condition. The condition was reduced to false, and then the if then else substitution took place, and it was replaced by one of the two phrases, and then the phrase was evaluated. So I know now that 1 plus 1 was not evaluated. For me, programming is representing. Since for me programming is represented, I wanted the minimal visual version of my language to be just not to be about controlling, nor controlling a computer, nor controlling a cartoon character. I wanted to be just about manipulating symbols, drawing symbols, evaluating symbols, seeing resulting symbols. There is no need to go beyond symbols to program with drawings. There are other versions of the visual environment. There is a version that allows to control, in this case, allows to control a robot. It allows to define classical behaviors in educational robotics, such as avoiding obstacles, going to the light, and combine those behaviors in more complex behaviors. I have shown how to define categories, such as Boolean. So the language does not need to provide predefined types, but rather allows them to be created. I have shown how to define notation. So again, the language does not need to provide special notation. We can create it. It is possible to parameterize code, as we have seen in the if then else. The addition, 1 plus 1 and 2 plus 2, they were code, and they were parameters of the if then else. They were the blue and red phrases. Defining notation, defining categories, parameterizing code, these three characteristics are not usual in visual languages for children. And when they appear at a cost, the cost of complexity. But here, with simple squares, simple drawings, one next to the other, ordered sequentially, separated in different lines, we could have these three features. With the language, it's also possible to program with text. There is an environment to program with text. I have defined natural numbers completely, fractions completely, exception handling. So having also a version of the same language, which is visual and textual, I think gives an opportunity in programming education. In programming education, there is usually a need to make a jump from visual languages to textual languages. And this is because when the complexity grows, sometimes the visual languages are limiting. Also, some domains are essentially textual. The natural numbers that we use today, which are positional, they came up along with writing. They are textual. So some domains need text to be implemented. I am working to offer one language that is also visual and textual, and keep it simple in two fundamental relations between symbols, substitution and categorization. And I'm working to offer a solution to this need of changing from visual to textual, which is do not change the language, instead change the tools for the different stages in the learning process. I think that if I go deeper in this path, I will reach that image that inspired me at the beginning, which was to be able to program with these magnetic blocks. I am working on that direction. I will show you an image. This is a photographic montage. This is how I imagine that programming with these magnetic blocks and drawings on paper and crayons could be implemented as a tangible user interface. The protagonist of this picture is Dionisio, my 10-year-old son that I told you about at the beginning of this talk. As Anand told you, there is a paper I wrote, a 17-pages paper. Here I presented some things like how to define notation, how to define categories, how to parameterize code, a readable applied loop console, and also a way to inspect the execution. But there is a lot more to show about this language. To anyone interested, I'll be glad to share a preprint copy of the paper I will present next month at Splash Conference. I hope you enjoyed the presentation. I am open to questions, ideas, suggestions right now during the Smalltalks conference, and also by email. Thank you very much.
I think your example with Boolean quantities is very important because in primary school, secondary school, general education, Booleans are disregarded. They are not present. And you can sense that when you offer software to adults with education, tertiary education, university degrees, etc. And they always they have the opportunity to write some expressions. You see expressions of the form true if true, true, if false, false. This kind of tautologies that they don't realize, or they transform constantly Booleans into numbers 1 and 0 because they are not equipped mentally with those quantities. So I think that visualizing Booleans and playing with them and naming them, representing them, because the reason why other people transform Booleans into numbers is because they don't have a representation, and you are given a very good representation, a graphical representation, so that becomes those become objects that are represented.
Yes, I agree. I think when you build something, you get to know it better. I am very familiarized with Booleans and natural numbers and implementation because in software engineering, we start with these examples. We made the students to start representing Booleans even when they have it in a Smalltalk. So we do it with prototypes. And the second exercise is representing natural numbers from scratch. Similarly, in the way I represented here with drawings, we do it first with sticks, and then they became Roman natural numbers. So, yes, I agree. This is a good way to start, and for children, even better.
You showed us a tool for visually creating code and logic. Have you tried this? Have you tried this tool on the? Is this tool available on the Smalltalk environment? Have you tried it? This tool integrated in a more sophisticated software development?
No, by now this is just a prototype that runs inside quiz, inside Smalltalk virtual machine. All the drawings and objects are morphs, so there is no implementation outside a Smalltalk environment.
And where else have you tried this? Have you field tested with children?
I didn't test this, well, with a little bit with my son, but not in a systematic way.
Okay.
This is part of my research next years.
Great. Thanks.
Any other question? Yeah.
Hi. Are you acquainted with Victor Red's dynamic land? What do you think about it? What are your thoughts about it? If you can compare
Yes,
your approach to
for me, well, the work, Brett Victor's work, it's very inspiring, and dynamic lang also. This picture of tangible user interface relates a lot with dynamic lang. The notion of tangible user interface is previous to Brett Victor's works. And well, I think if we can use our hands and our body, etc., to program, we will do it better. I think that programming is not about the computer. It's something, the computer is a tool, like in other disciplines, like in photography. It's not about a photographic camera, but the powers that gives the camera to the photographer, it's enormous. So here the computer gives us power, but it's not about this gadget, as said by Abelson and Sussman. So I want to put programming, outside the screen, fundamentally outside the screen. To my son, all the time we talk about if he can have some screen time. So the time in front of a screen is something that is limited for him. So 1 hour, 2 hours, 3 hours, no more in a day. If we can program outside the screen, well, it will be healthier.
Last question.
Does this language have any limitations regarding on what you can do, what you can compute? Like it's a complete language?
It's a general purpose programming language. It's complete. In the visual version, there are some limits. It's not, you cannot do a complete representation of natural numbers as in the textual version. There are some limits. In the textual version also, there are some syntax added. For instance, I use parentheses to express that in a sentence, some part of the sentence should be evaluated first and then the whole. Similarly, as in a Smalltalk, no? When in an expression, some part of it should be evaluated first, we use parentheses.
Seems pretty accidental, right? Because if you could come up with a layout, symbol, something that represents that previous evaluation, you can solve it within the visual context you already created. Wouldn't that be?
I want to interpret your question. There is a way, yes, to define syntax or to define relations that express substitution relations in the same way that we define it if then else, to express that certain part of an expression should be evaluated first. The visual version, it is implemented on the textual version. So what you see as visual symbols, there are substitution relations running behind that are defined with text. And we can use them to draw symbols that express that certain part of an expression should be evaluated first and then the whole. Another thing about the evaluation is that the language takes all the expression and tries to evaluate it completely, and then go by parts. Usually a language, a syntactic language, starts with little things. Well, this is an object, a message, and then to that I send a message. So it starts from little expressions to bigger ones. This is opposite. First the whole, and if the whole cannot be reduced, cannot be substituted, then it goes by parts.
Okay.
Thank you.